So hello everyone, in this audio class we will discuss the 20 most important questions from the chapter Spatial Information Technology. These questions will be very much important for your upcoming KVS and NVS Geography PGT interview. So let's get started with the question number 1. What do you understand by Spatial Information Technology? So Spatial Information Technology refers to a group of technologies used for collecting, storing, processing, analyzing and presenting geographical information. It mainly includes remote sensing, GIS, GPS and digital cartography. The main purpose of spatial information technology is to understand spatial relationships among different geographical phenomena. For example, if we want to identify flood prone areas in West Bengal, we can combine satellite images, elevation data and rainfall information using GIS. Thus, spatial information technology helps in scientific decision making and planning. So, the next question is, why is spatial information different from ordinary information? So ordinary information only tells us about the characteristics of an object, whereas spatial information tells us both what the object is and where it is located. Every spatial data has two components, location component and attribute component. For example, a school record may contain the name of the school, number of students and teachers. These are attributes. But when we add latitude and longitude of that school, it becomes spatial information. Therefore, spatial information connects data with geographic location. So the next question is, what are the major components of spatial information technology? So there are four major components of that is remote sensing, GIS, GPS and digital cartography. Remote sensing collects information from satellite, GPS determines accurate location and on the earth surface, and GIS stores, manages and analyzes spatial data. Digital cartography prepares and represents maps in digital form. For example, during cyclone forecasting, satellites collect data, GPS provides location, GIS analyzes risk zones and digital maps communicate the results to people. So the next question is, what is GIS and why is it considered the core of spatial information technology? So GIS or Geographical Information System is a computer based system used for capturing, storing, managing, analyzing and displaying geographically referenced information. It is called the core of spatial information technology because GIS integrates information obtained from different sources such as satellite images, GPS observations, sensors data and field surveys. For example, if a government wants to select a suitable location for a new hospital, GIS can analyze population density, road networks and existing healthcare facilities together. Therefore, GIS acts as an intelligent decision support system. Next question, can you explain GIS with a practical example? So yes, suppose the government wants to identify the best location for a school, for a new school. First, GIS collects layers such as population distribution, road connectivity, settlement pattern, existing schools, etc. Then these layers are overlaid and analyzed together. Areas with high population, good road access and fewer schools are identified as suitable locations. This process demonstrates how GIS supports planning through spatial analysis. The strength of GIS lies in its ability to analyze multiple layers of information simultaneously. So the next question is, what do you mean by a GIS layer? So a GIS layer is a collection of geographic features representing one theme or phenomenon. For example, road one layer, rivers one layer, population one layer, land use, this is also one layer. GIS works by stacking these layers together. For example, to identify flood prone areas, we may overlay river layer, rainfall layer, elevation layer, settlement layer. This layered approach is the foundation of GIS analysis. Next question, why is the layer concept important in GIS? So the layer concept allows us to analyze different geographical factors separately and then combine them. For example, when selecting a site for an airport, we must consider flat land, low population density, good transportation access, distance from forests. Each factor can be represented as a separate layer. GIS combines these layers and helps identify the most suitable location scientifically. Next question, what are spatial data and attribute data? So spatial data describe the location and shape of an object, and attribute data describe its characteristics. For example, a hospital on a map. Spatial data, its longitude, latitude, shape and location. And attribute data, hospital name, number of beds, number of doctors. Both types of data are necessary for meaningful GIS analysis. Next question, what is the difference between raster and vector data? So raster data consists of grid cells or pixels, and vector data consists of points, lines and polygons. For example, raster data is satellite images, temperature maps, rainfall distribution, and vector data cities using points, roads using lines, and district boundaries using polygons. Raster is suitable for continuous phenomena, whereas vector is suitable for discrete features. Next question, which is better, raster or vector? So neither is universally better. The choice depends on the purpose. Raster is preferred for remote sensing, temperature mapping, rainfall analysis, and vector is preferred for road networks, administrative boundaries, urban planning. So a good GIS project often uses both formats. So the next question is, what is overlay analysis in GIS and why is it important? So overlay analysis is one of the most important GIS operations. It involves superimposing two or more thematic layers to generate new information. The basic principle is that geographical phenomena are interrelated and combined analysis can support decision making. For example, if we overlay rainfall, soil type and slope maps, we can identify suitable agricultural zones. Similarly, by overlaying population density, road network and healthcare facilities, we can determine suitable locations for new hospitals. Therefore, overlay analysis transforms raw data into useful geographical information. Next question, can you explain overlay analysis with a real life example? So suppose the government wants to identify flood prone areas. A single factor cannot explain flood risk. Therefore, GIS overlays multiple layers such as rainfall, river network, elevation, drainage density and settlement distribution. Areas where high rainfall coincides with low elevations, and then settlements are identified as high risk zones. Thus, overlay analysis helps in disaster preparedness and resource allocation. This demonstrates how GIS converts multiple data sets into meaningful decisions. Next question, what is buffer analysis? So a buffer analysis is a GIS operation that creates a zone around a geographical feature at a specified distance. The purpose is to study the influence of a feature on its surrounding area. For example, if a school is located within 500 meters of a highway, students may be affected by noise pollution. By creating a 50-meter buffer around highways, planners can identify sensitive locations. Therefore, buffer analysis is widely used in environmental management, urban planning and public service delivery. Next question, give some practical applications of buffer analysis. So buffer analysis has numerous applications. Around rivers, it helps identify flood risk zones. Around industries, it helps assess pollution impact. Around hospitals, it helps evaluate healthcare accessibility. Around roads, it helps analyze transport influence. For example, during COVID-19, GIS was used to create buffer zones around infected locations to monitor disease spread. Thus, buffer analysis helps planners understand spatial influence and proximity relationships. Next question, what is network analysis in GIS? So network analysis is used to study movement along interconnected pathways such as roads, railways or pipelines. It helps determine the shortest path, fastest route and optimal connectivity between locations. For example, Google Maps uses network analysis to suggest the quickest route between two places. In urban planning, it helps optimize transportation systems and emergency response services. Therefore, network analysis improves efficiency in movement and resource allocation. Next question, what is a GPS and how does it work? So GPS or Global Positioning System is a satellite based navigation system that provides accurate location information anywhere on Earth. GPS receivers calculate their position by receiving signals from multiple satellites. At least 4 satellites are generally required to determine precise latitude, longitude and elevation. For example, when we use navigation apps on a smartphone, GPS helps identify our exact location and guides us to the destination. Thus, GPS has become an essential tool for navigation, surveying and field data collection. Next question, how is GPS useful in geography? So GPS has transformed geographical studies by providing highly accurate positional information. It is used in field surveys, mapping, disaster management, transportation and environmental monitoring. For example, during a land use survey, a geographer can record the exact coordinates of observation points using GPS. Similarly, disaster response teams use GPS to locate affected areas and coordinate rescue operations. Therefore, GPS improves accuracy, efficiency and reliability in geographical investigations. Next question, what is remote sensing and how is it related to GIS? So remote sensing is the science of obtaining information about Earth's surface without direct physical contact. It mainly uses satellites and sensors to collect data. GIS and remote sensing are closely related because remote sensing provides data while GIS stores, analyzes and interprets that data. For example, satellite imagery can show changes in forest cover, and GIS can quantify the extent of deforestation and identify affected regions. Thus, remote sensing and GIS complement each other in geographical analysis. Next question, what are the major applications of spatial information technology? So spatial information technology has applications in almost every field of geography and planning. It is used in urban planning, agriculture, disaster management, transportation, environmental monitoring, resource management and public health. For example, GIS helps identify suitable sites for industries, monitor urban growth, and predict flood-prone areas. During cyclones, satellite data and GIS support early warning systems and evacuation planning. Therefore, spatial information technology plays a vital role in sustainable development and informed decision making. Next question, and this is the last question for today. What are the limitations of GIS and spatial information technology? So despite its advantages, GIS has certain limitations. It requires large amounts of accurate data, specialized software, and trained personnel. Data collection and updating can be expensive and time consuming. Errors in input data may lead to incorrect analysis and decisions. For example, if outdated population data are used in urban planning, the resulting decisions may not meet the current needs. Therefore, while GIS is a powerful tool, its effectiveness depends on data quality and proper interpretation. So there is a final question from this chapter. Bonus question, this is very important. If you are teaching spatial information technology in a classroom, how would you explain it to a student? So I would begin with a simple real life example familiar to students. Suppose we want to find the nearest hospital from our school. We need to know where the hospital is located, which roads connect it, and how long it takes to reach there. This information involves location, distance, and spatial relationships. Spatial information technology helps us collect, analyze, and display such information scientifically. Then I would explain the spatial information technology consists of remote sensing, GPS, GIS, and digital cartography. Remote sensing collects data, GPS identifies location, GIS analyzes information, and digital cartography presents it through maps. Finally, I would connect the topic with the daily life applications such as Google Maps, weather forecasting, disaster management, and urban planning. This approach helps students understand that geography is not merely descriptive, but it is also analytical and technology oriented. So thanks for listening. Keep listening for further audio classes. Thank you.